Good day everybody, we got a beautiful question. Foremost, let me draw the quarter circle. We need two quarter circles. This is actually present inside a square. And you got the next one stemming from here. The circle is making a point of contact with the other two quarter circles. I'm going to refer this circle which stems from A to be as circle 1 and the circle which stems from B to be as circle 2. Now clearly you can see that the small circle has a point of contact with the two circles. So let me take this point of contact as some E, and this point of contact as some F, and there is a tangent at, say, let me take this as H, right, with the side of the square. Now, having mentioned this, foremost what I wish to do is I would like to utilize a very important theorem. Now what is the theorem? Let me state the theorem here. If there is a solution, if a line were to be drawn through the point of contact of the small circle, so what I'm going to do is I'm going to be considering the point of contact of the small circle with this C1. So that's exactly what I'm going to do. If I'm going to represent it by this sentence, if a line were to be drawn through the point of contact of the small circle with circle 1, the line would pass through the centers. So that would mean, since there is a point of contact here, if I were to draw a line through this point of contact, then that line would actually connect the centers of the circle. So that is the main concept we will be utilizing here. So if I were to take this point as some O, then I can utilize this information. OB from the figure we observe that OB is equal to BE plus OE, right? Now what is BE? Now we've been given the sides to be as 4 units. So this is 4 units, this is 4 units, 4 units, 4 units. Now from this point, this is the center, from the center to the point on the circle, that is 4 units. So this would mean the radius of these circles, the 2 quarter circles, are 4 units. So BE is equal to 4 units plus my OE. OE is the radius of a small circle. So I'm going to take it as R. We take the radius of the small circle to be equal to R units. So this would mean our OB is equal to 4 positive R. So that's an important information we have secured. Okay, having secured that information, what I wish to do is I would now take in this point of contact. You can clearly see that this is the step 2. Step 2, the small circle also has a point of contact with circle 2. So if we were to draw a line through the point of contact POC, then the line would connect the centers of the circles. Okay, so what I wish to do is, my C2 center is over here. So if I were to draw a line with, or I should say through the point of contact, then that line will connect the centers of small circle as well as the center of this C2, right? Because this C2 is in consideration here, over here C1 is in consideration, so that is very critical. Okay, so now what I wish to do is, this is the next step. Step number 3, we will drop a perpendicular line from O to AB. So let's do that. If I were to drop a perpendicular line from O to AB meeting at H. So let me do that. So this is going to be H, is a perpendicular drawn. So this is 90 and this side is also be 90. Now the question is, what is AH? Now to get AH, we will, its AH is already there, so I need to change that. So instead of saying H, I will change it to some P. We will meeting at P. Right, H is already placed H there. So we will drop a perpendicular line from O to AB meeting at P. Now the question is, what is AP? Now clearly we see AP will be equal to OH, right? clearly AP, if you have to draw a line like this, say from O, that's going to be the radius, right? OH and AP will be one and the same. So clearly I'm going to write it here. AP is equal to OH is equal to R. This would mean my AP is equal to R. So that's one point. Now what I wish to do is, I would like to, you can clearly see there are two right angles. Okay, so first I will consider PBO. Let us consider triangle BPO. Since it's right triangle, we can use Pythagoras. We can use Pythagoras theorem. So by Pythagoras theorem, what do we get? We get BP squared plus OP squared is equal to OB squared. Now this can be rewritten as OP squared is equal to OB squared negative BP squared. My OB squared is 4 positive R raised to the power of 2. My BP squared, BP, this entire length is 4 units, but this is R. We have to take away this, so 4 minus R. So from 4 units you take away this, so you get BP. So 4 minus R the whole squared is equal to OP squared. So this is one system. I'm taking it as equation 2. Now step number, I'm going to fill it here, I'm going to place in here. Step number 4, consider this triangle APO. Consider triangle APO by Pythagoras. It's a right triangle. We get, so what do we get by Pythagoras? AP squared plus OP squared. AP squared plus OP squared is equal to OA squared. And from here, OP squared is equal to OA squared minus AP squared. And OA squared, what is OA squared? Now this entire, from the center to the point on the circle, that's 4 units. You take away R, so it's going to be 4 negative R whole squared. Negative AP squared is R squared, so R squared. This is going to be OP squared. So I'm going to take it as 3. Now clearly you can see 3 and 2 can be connected together. So what I wish to do is I will use this part of the right. So let me write that down. Using 2 and 3 we get, so what do we get using 2 and 3? This is 4 positive R raised to the power of 2, write that down. 4 positive R raised to the power of 2 negative 4 negative R raised to the power of 2 is equal to this one, 4 negative R raised to the power of 2 negative R squared. We find the value of R here. So this is 4 squared negative 8R negative, this is going to be positive R squared negative R squared, right? Expanded by a negative b raised to the power of 2. So positive negative they get cancelled. Over here you get 4 squared positive 8R positive R squared negative 4 squared. This is going to be negative 8R, so that will be positive 8R, and positive R squared, that will be negative R squared. So negative positive gets cancelled, positive negative gets cancelled. You add these two things, you get 16R, and then you can push this to the other side, you get positive 8R. This is 16. So 8 added with 16, that's going to be 24. R is equal to 16. So R is equal to 16 divided by 8, should be 24, right? So 4 will divide here, 6 4s are 24, 4 4s are 16. Again 2 will divide here, I should say 2 will divide here, 2 times 2 will divide here 3 times. So the value of r is 2 over 3, right? Now we need to get the radius of the circle, small circle. So therefore I'm using this part of the page. Radius of small circle is equal to pi r squared, which is equal to pi times, this is 2 over 3 r squared, which is equal to 2 squared is 4, pi 3 squared is 9, so 4 over 9 pi square units. This is the solution. Now I want to give you a small task. Okay, so we had, this is a solution. The solution is already done. We completed the beautiful question. It's a lovely question. Now what I wish to ask you is, what would you do, or how would you calculate the radius of this circle if the circle is present over here? If the circle is present over here, it makes a contact with the two circles, the circle 1 and the circle 2. There is a point of contact here, and I want to find out the radius r. It is not over here, it is inside, right? The question is different. So this is your work. Put in your solutions, I will check the solutions and I will give you a score. Thank you everybody, enjoy your day until we meet again.